Hello, everybody. Good morning, good evening, good afternoon. Good to be with you here. It's morning for me in California. So welcome to our webinar and welcome to my home office. I usually get a green screen there, but I put the green screen down. I was missing my background. So we started like this. Let me get here the PowerPoint slide to share with you. Here we go. Let me go ahead and share my screens. This one. There we go. So I believe you can see my screen now. Let me see. Yeah, can you confirm you can see my screen? Please. Anybody in the call? You can use the chat window.
We can see it.
You see it?
Yep.
All right, perfect. So welcome to our webinar on Power BI and on a particular feature of Power BI called Power BI Aggregates. And Power BI Aggregates is a feature that was introduced a couple years ago. Still not that very popular. People don't. Actually, it's kind of easy to mix up with regular aggregations we do on any BI tool. And this particular one is not your regular, sum, average aggregations you do on your data set. That's a particular feature that was introduced into Power BI to kind of go over the limits of Power BI capacity of processing data, which is super cool. And we kind of have a nickname to it. We call it aggs, like it's showing there on the slide deck. No, Power BI aggs, AGG, not EGG. And we're gonna dive into that in a few. Let's just get started here with some introductions. My name is Armando Lacerda. So if it's the first time we are together on a webinar, it's great to be with you here. I'm a senior cloud data solution architect for Wintellect. I work with Wintellect along with an excellent group of people, all specialists on their areas. I'm also a Microsoft MVP, which stands for Most Valuable Professional. And being an MVP, it's the MVP title is kind of an award. It is actually an award that Microsoft gives to people who likes to do things like I'm doing now, to share the knowledge for free with the community. So if you're interested, you can become an MVP too. Just start, sharing your experience and your what you know about technology, and in particular with about Microsoft. And you can get there right when you show your technical skills and share with the community. So that's the MVP side of my profile. I'm also a certified trainer for Microsoft. I've been a certified trainer for 25 years. I just turned 25 years this year, this month, April. I've been teaching Microsoft classes on multiple subjects, from infrastructure through development, and my particular field for the past 20 years, which is databases, right? Databases and data platform. We also got some of my certifications down there. Microsoft has switched the certification profile from system engineers and system architect. Yeah, from those old certifications they had to new ones based on badges. So now they have the expert level, they have the associate level, and yeah, taking these certifications is one of the things I like to do, because it's important they kind of show you you have skills, and Microsoft can attest that you do manage those technologies. So those are a few of them. Power BI, of course, is included, and Azure Data Platform is included there. If you like to get connected with me, I would love to, be part of your network, social network on the web. My preferred channel is preferred social media, right? Social network is LinkedIn. So if you would like, I would love for you to go ahead and connect there with me on LinkedIn. I usually share some blogs or short snippets of things that are coming through Microsoft, or something new that's coming through Microsoft and other data related platforms. I do have a Twitter handle. I do not tweet much. And the Facebook side of it is more of the personal one. So if you want to watch me riding my bike someplace, that is where you're gonna find pictures about that, and family and so on. Wintellect, like I said, the company I work for, is a consulting and a training company. We just had a merge with another company here in Portland called Lacerda. So now it's Wintellect, Lacerda Wintellect. We are working together. We blended our companies and to make to work together and have a better, larger portfolio of service to our clients. So we do consulting on the cloud platform. We do consulting on infrastructure. We do consulting in data platform, like I'm a specialist on that side in there. We also do instructor-led training, both. I mean, when COVID allows, when COVID is gone, on premises, right at the site. We've been doing live online for during COVID and way before, but especially now through COVID, and also on demand, which is the Wintellect now, which pre-recorded videos, right, with the classes. They're awesome videos, first graded lessons in there, and that's based on demand. And I invite you to go ahead and check the website later after this session, right? So consulting and training and Wintellect now. We also, a lot of our collaborators at Wintellect, they're well known for the books they have published. This is a few of the books that have been published in the past. And if you're a developer, more likely you have seen or you have read one of these books. And see, they were written by people in that work with us. So great source for you to support you in your projects. All right, so let's get into our subject in here for the next 15 minutes or so. We're gonna go into this particular feature of Power BI, which is the aggregations, and when it applies, right? We're gonna understand how Power BI works internally in some aspects and when it applies, when this particular feature applies. And of course, I will have demonstrations going around those things. And I'm rooting here that the demo gods will help me out, because I was warming up my environment just before this session. I got some timeouts going on this on the Azure side. I hope it stabilizes. We'll see. But Power BI, I was just talking about that before this session here with somebody on the call. Power BI has hundreds of features, right? There's so many things you can leverage in Power BI, from the basic stuff like the visualizations and all the elements, all the features that are common to all visualizations, and some that are specific to an individual visualization. So it starts from there and goes into all the tooling we have for Power BI, both developed by Microsoft and by the community. Now Power BI Desktop incorporates tools developed by the community, which is super cool. So we have all of those elements in Power BI, so there's tons of features. In this particular session, we're going to look into one that is designed to help Power BI deployment specifically on enterprise use cases, where the data that needs to be conveyed through Power BI cannot fit into Power BI's limits, right? So we're going to go through that, but I want to set the perspective here, the goal, where are we heading, right? There are a bunch of other things we could talk about in Power BI, but this particular one, the theme for today is on that feature that's used on a particular case when the data you're trying to handle inside Power BI doesn't fit inside Power BI. All right, so with that said, let's go ahead and check some of the slide animations I have done here for you, and also check some of the demos. So this particular case, this particular business case for aggs, it's usually for enterprise cases. You don't see that when you are working with regular use cases. Remember that Power BI was designed originally for end user consumption. Actually, Power BI, for the most part, is under the Office 365 umbrella, right? You get Power BI Pro licenses through Office 365 umbrella. Now you can have Power BI Premium, right? Outside that, Office 365, you can get the A series through Azure. But for the most part, Power BI is managed and licensed through, Office 365, which gives you the idea that Power BI is sort of an end user tool, right? It's like Word, Excel, PowerPoint. It's kind of an end user tool in a way. But of course, being a BI tool and with the idea, the goal of democratize BI implementations, there's always those cases where the business case or the problem to be solved is too technical for regular use to work with. And this is one of them, right? When it gets too much data, and it's not just a spreadsheet that the user wants to import into Power BI or an Access database that you try to import to Power BI. It's actually something more complex than that. So let's take a look. Regular cases, like I was saying, regular cases of Power BI. So what you have is people go get Power BI desktop, and they want to create those reports in Power BI. So they get all the visuals, they organize the whole thing, publish to the service, and off you go, right? You can have dashboards and everything else. So we connect Power BI to whatever regular data source, like I just mentioned, Excel, text files, PDFs, web pages, right? You can point to websites and collect tables that are published in web pages and collect the data from there. We can get all of these disparate data sources from multiple formats, blend them together inside Power BI, and publish to the service. You know that when we do this, what we are actually doing is on our local machine, if you are using Power BI desktop to develop your report, what you're doing is creating this PBIX file in your local computer. And when you publish, the content of that file is broken down into pieces and publishes like reports and data sets and other elements that may exist in there. Here's the thing. While you are using Power BI desktop, your limit is, or the limits that are imposed to Power BI is your workstation. So how much data can Power BI import at this point? It depends on your computer's memory, your physical memory on your computer, right? If you're using a laptop, right, whatever memory is in your laptop. In my case here, I have 32 gigabytes of RAM in my laptop. So we discount some of the softwares that are there. Probably can import a 20 gigabyte data set into my Power BI desktop, which is super large, right? It can get a lot of data in this in an environment like this. But that works on my laptop. When I push this thing out to the cloud, when I push my report and the data set along with it to Power BI service, then the limitations show up over there. So first thing you need, if you're new to Power BI, is to understand that there are two limits to consider. One is the limit of your computer, and the other is the limit of the service, the Power BI service. And usually we get our content in the service because we want to share with everybody else. If you if you're working in a company, you want other people to look into your report, you want to share your report. So the limits that really apply are the limits that are in the service. So that Power BI file that's created on your local computer can work well for you on your computer, but may not work on a service. Because when it's working on your computer, it depends on the RAM memory of your computer, and whatever size is there is whatever data it can bring in. But when it goes to the service, it doesn't work like that. All right, so that's the picture we have for desktop local processing of the file. And let's go ahead to our first demo and see that working. So for the demo, I do have here a virtual machine that I was connecting to. I'm already connecting the virtual machine. I'm just connecting to the Azure portal so I can run some demos here for you to see. And it's asking for multi-factor authentication. So let me get here to the Authenticator app. And yeah, send it, approve it, off it goes. All right, here we are. So I'm gonna open up Power BI desktop here, a brand new one, so we can see that particular connection going. But in my case here, while Power BI is loading, I already have the other two Power BIs for the next two demos open in there. Just for you to understand the environment we're working with and the kind of data we are working with, I have this data lake here that is supplied by both the city of New York. They make the data set available publicly, and Microsoft grabbed that data set and kind of already arranged it for demos like this, which is the New York City taxi public information, right? So it's kind of cleaned up in order to remove PII information, but we do have the information of every single ride in New York City for the yellow cab, for the green cab, for Uber, and all other rideshare services in there. So they make that data available, and I do have that data in here in my Azure subscription that I have for this this session. So if I go here into containers, this is my data lake. I can see here New York City, New York tax cab. And in here, I have the multiple data sets. One of them is this yellow one here. So Power BI, as of today, it seems is on the roadmap to support it in the near future, but as of today, cannot really tap the data lake straight through, right? Because this is in Parquet files, what we have in here. If it was CSV files, we could work right with CSV files, but these are stored in Parquet files, as you can see. So Power BI cannot really query this. So what we have, what I have made for us in here, is a Synapse workspace. And I'm gonna, from this Synapse workspace, I'm gonna leverage the Synapse serverless SQL pool. So it's blowing up the environment in here. There we go. And let's see. So if I go here, of course, this session is not about Synapse. I just want to show you where the data is coming from and the size of the data, right? The volume of the data I have in here. So if I go in here into the databases, I see that there are showing there are two databases, right? So there is one on a dedicated SQL pool, and there is one on a serverless SQL pool, and this is the one we're going to be working on, this New York taxi cab yellow, right? So if I go there into the development notebook, and I think I have some tests in here to show you that. So there we go. These queries here are ad hoc queries going into the lake and collecting data from the lake. So this is when you do like ad hoc queries to the lake from Synapse. I also have, let me get here a new editor, a database already created with some objects already there. So if I go here, select star from, whoops, select star from systables, for instance. And this one here, I see I already have a table in here called New York City cab external table. Is a pointer to the external table that is in the lake, right? So this table here is the one with all the rides, right? Information about all the rides in there. So if I do here a select count star from dbo.New York tax cab external table, there it is for me, and I do this one, you see that we have billions of rows on this particular table. And this is the table on this first demo that I'm going to tap and try to bring into Power BI, right? We'll see that that's going to be a problem with that because it's not going to fit. So while it's counting that one, let me go ahead and get connected. So to get connected to that serverless endpoint, I use this particular URL here. So let's go and connect. Get data. There we are. And that's although it's Synapse up in the cloud, it connects like it's the SQL database. So I can just go ahead and select the SQL server as a source, even though, like I said, it's Synapse. But because it's SQL Server Synapse, it is you use the same data driver for connection there. And the database name here is, what's the database name again? Oh, I already have a number there, perfect. So it's New York Tax Cab Yellow. So hopefully I can type that. New York Tax Cab Yellow. Make sure I got it right. Taxi cab yellow. Yeah, that seems right. And you see, in Power BI, Power BI has two ways to connect to data sources. One is tap the data source, bring the data into Power BI, compress, make it super fast, super tailored for fast data query inside the Power BI engine. That's called import. Or you do direct query. So when you do direct query, you are giving up on the best things that Power BI can do for you, right? Which manage your data and have super fast access to your data. When you do direct query, you're always going back to the source, which in this case would be always going back to Synapse. And that could be not just slower, that will be not just slower, but could also be costier. It may cost you more going back to Synapse all the time. Every time someone plays, changes anything in your report, clicks on a visual or changes any filter parameter, that can become really costly and somewhat frustrating because, like I said, it's low for most cases, especially when it's super large data like this one here. So what we're going to do is usually import. Let's go ahead and do the import in there. And again, when we do the import into Power BI, is when we bring the data into memory. Like you can remember from the slide deck, the memory you have on your computer or in service, whatever data you bring has to fit in a memory, right? That's what we have in here. So here are some of the tables I have in there in Synapse, right? In my remote system, my remote data source, and there is one in here for the trips. So I think it's this one, right? This is one for the trips. It's the one we checked there before. By the way, let's double check in there. This is the amount of rows we have in there. So how many rows do we have? Let's see, comma here, and comma here. So we got about a billion and a half, right? Rows. Perfect. So yep, this is the rows I want to get loaded into Power BI, and I go ahead and hit load. This is what a regular user in a regular case, in a regular scenario would do. Get the rows there into from the database and bring it to Power BI as an import. That's the way we want to work with Power BI. The problem, again, like I said, on an enterprise level, the level we are working here, this will not fit in memory. Even though I have 30 gigabytes of RAM on my computer, this Power BI we are looking at right now is running on a VM inside my computer, not in Azure, but it's local to my computer. And as it runs inside the VM is a limited memory in the VM, of course, so to make sure that the demonstration will work. So while this is running, we go back to this one here in a few, but while this one is running here, going to move ahead to the next step. We know that this will fail, right? It's going to take a little while, but we know that this will fail because it will not fit in memory, so you're going to have an error there about the memory. All right, so let's go back to the slide deck, and I will still waiting on the data coming from there. So we will go back to this one here, see the error momentarily. So in the previous animations were about enterprise Power BI cases, were about regular business cases, and this now is for the enterprise case, which was kind of the demo we have just seen. So when you go into Synapse, when you go into perhaps a larger SQL, regular SQL server, or when you're using Databricks to go into the lake and do some transformations and supply some data for Power BI, or regular Spark, right, from other vendors, which Synapse is one of them, by the way. So when you tap into these larger data sources, what ends up is the data doesn't fit in memory. It's not going to fit in there, and you're going to get the error we'll see in a few. So when that happens, what do you do? One of the solutions that you can apply or can deploy is detaching the data engine that exists inside Power BI and run it aside of Power BI. So that's one option, right? The other option is, even before doing this one here, is using Power BI Premium. So in Power BI Premium, your 1 gigabyte your 1 gigabyte dataset limit can grow to, I think the initial one is 14 gigabytes. So you can get up to 14 gigabytes of data compressed. And if you keep going to premium, you can get larger numbers. But when you are working like 400 gigabytes of data, compressed data, Power BI Premium doesn't support that yet. So you have to, like I said in this slide here, trying to depict in this slide, you detach from Power BI, the data engine from the Power BI environment, and you leverage Power BI, you leverage Azure Analysis Service, right? So that icon over there, this icon here is actually about represents Azure Analysis Service. So the problem when you do that is you add a lot of a complexity into your solution, because when you are doing, oops, hold on, my mouse is in a different place. So let me do this again. There we go. So when you do Power BI only, let me use the laser point, it's probably better. Laser point, there we go. When you use Power BI only, you can use Power BI Desktop to do all your development, right? To import the data, to get the data ready, move up to the cloud. When you have to detach from Power BI into analysis service, like I said, you're increasing the complexity of your solution, because now you have to start working with some extra tools, because Power BI Desktop doesn't manage an Azure Analysis Service. So you have to get Visual Studio involved, you get to get SQL Server Management Studio involved, and also you're gonna need extension, the Visual Studio extension for the data tools extension for Visual Studio involved, so we can handle things going on here into analysis service. So you see, it kind of get things a little bit more complicated just because the data didn't fit. And in any case, as you push more data in, you have to scale analysis service further and further up, and there is a limit for that one too. So at some point, you may even hit that particular limit, which is always frustrating. So an alternative to this, and let me go back to the demo, an alternative to this is the aggregations, which is the thing I will demonstrate to you momentarily. And it's still pushing, still waiting for the data to come in to fill out. I'm gonna leave this working here in the background, and you're gonna see this error message in a second. So the other thing we can do is reducing the granularity of the data we want to bring from the source. So and this is the next demo here, this one. So for instance, hold on just a second. Oh, look at that. Demo gods are not helping today. That's these two things here to refresh, see if they refresh this time. But let me get back in here on this guy. So in this Power BI file that I have already created, I have defined a different approach by just reducing the amount of data. So this is my trips table, right? The table we have seen that 1.5 billion rows in that table. So that table has a lot of information here, a lot of metrics. If I zoom in here, you see there are a lot of columns here about metrics like tolls, tip, total amount of the ride, and so on. And there are a lot of dimensions to it, right? Like you get the vendor ID, who made the ride go, who recorded the ride, passenger count, how many passengers were there. So kind of it's not actually a metric, right? It's kind of dimension. Could be a metric, but kind of a dimension here. The location ID, where the ride started, and so on. So if I look at the table, I have more dimensions in here, like a latitude, longitude, a rate code. I have a bunch of other informations in here that I could use as dimensions. But if I need to bring that data that doesn't fit in Power BI into Power BI, another thing I can do is this thing here, right? It's this approach is to reduce the granularity of the data. The point here is get to a compromise where people would tell me, my users, my business users would tell me, we have all of this data, but I don't need to get access to this entire data. What I do need mostly, for the most part, is query this information, all this information about the tools in there, aggregated or filtered by this, in this case here, in this simple example, aggregated or filtered by these 4 dimensions. So if I can get to that compromise and I can reduce the data set, the information I'm bringing enough, I will definitely be able to bring it into my data set, which is, an okay approach, but always is a compromise. It's like I'm not bringing all the data that I have. Even worse, I'm not giving access to all of the data that I have. So this approach here has been a very common one that people have been using, but again, it's kind of a compromise and doesn't really hit the mark. And what would the mark be? The mark would be allowing people to browse the data quickly in Power BI speed, right? Power BI speed, Power BI performance for the most part. And when the users need granular specific data that was not brought into Power BI, we want to go back to the data source and collect that information. That's when a performance tool would be paid, but it's for kind of for the edge cases, right? For the not so frequently queried data into the data set. So that's where when aggregations works, where aggs works. So this is the actual core of this demonstration and this webinar. Again, we do have a fact table. If you're familiar with data modeling, you know that when we do BI, we usually choose in between star schema or snowflake schema for data modeling when arrange the data coming from multiple systems into our data house or our data mart. So we kind of arrange our tables in these 2 categories, right? They're star schema or snowflake. In this case here, I got a star schema. It's usually the recommended one, the one you get better performance for the most part. Snowflake can help, model can help sometimes, but for the most part, star schema is the preferred one. So if my database, in this case here, got one fact table and multiple dimensions, if I bring all of them, it won't fit in Power BI, which the demo is still waiting for the thing to fail. So it wouldn't fit in Power BI. If I compromise it and say, you know what, I'm not going to bring all the dimensions, I'm going to bring part of these dimensions, just a partial collection of these dimensions, then I'm making that compromise of just a portion of the data, but not the entire data, and not allowing the users to see the full data. But if I do aggregations like we're seeing here, we are doing a similar process. We are going to choose, like in this case here for orders, we're going to choose which dimensions are more commonly used. And that's usually something that the business would tell us, right? So business would tell me, you know what, when I look into this data here, into the orders table, I usually search or aggregate by geography, by customer, the customer who bought the product or placed the order, promotion, and all these dimensions here. These other dimensions, they are not really as important. And if I get to those, like I said, I can pay a performance penalty just to see the granular data that exists in there. By reducing the amount of dimensions I bring into Power BI, the fact table gets smaller, right? It kind of doesn't show that much in here. I try to, but doesn't seem that smaller in this case. But it does get smaller when, there we go. I knew I have done it. it does get smaller because inside Power BI, we're going to aggregate the data that's the original data that's in the source to whatever collection of dimensions we decide to bring in. And what aggregate will do is it will have a link to tell Power BI if someone uses one of the dimensions that were left out, you go back to the data source and read data from the data source. That's what this animation here will show. So you have Power BI, presenting the report in Power BI service. You have your super large data set, in our case here, the text database in Synapse, right, in my data lake. You have a super large data set here, and you're gonna hit back to it through direct query. But you're gonna bring some of that data partially, according to business case like we just mentioned, partial collection of that data into Power BI as an import mode. So I want to import that data, I want to bring that data in. And of course, you're going to do that with the mindset, being aware of, conscious about, of your memory limitations. So if you're doing Power BI Pro, your data sets can only be up to 1 gigabyte. So whatever compromise you're doing here, you're bringing data that will be compressed up to 1 gigabyte. And if you're doing Power BI Premium or analysis services with live connection to Power BI, whatever memory capacity you have on those services, right? But the point is, you're gonna make a data set that is large enough to fit in memory, right? It's not too much information that will not fit in memory. And you're gonna tell Power BI, look, I am publishing this data and creating reports on this data based on this table and dimensions, right? And this fact and dimensions, but it's based on that one down there that has more dimensions to it than the one is in here. So if a user creates a report and makes a visualization, puts a visualization in the report that hits the fact table with one of these dimensions in here, Power BI will not make this direct query. While on the other end, if it was requested to actually count or aggregate or make separation by one of the dimensions that's not included in here, Power BI will leverage both whatever data can be brought from here and also hit back to direct query. So as you can see, it's the best of both worlds, right? It's the best of two possibilities. As much as I can work in memory, I work in memory, and when it's not possible, I go back into the original data source. Now, one thing to keep in mind here is, notice that in this one here, I have 5 dimensions, right? But, for this particular example, while total here, I have 8 dimensions. So if I pre-select some of the dimensions in here for filtering, and I pick another one in here that's not over here for filtering as well, what ends up happening is, even though I have 1.5 billion rows in here, because I have already filtered the data set, or I should have filtered the data set beforehand, the amount of rows going from here to here should be small enough, few enough to be selected, collected, and sent over faster than 100 billion rows in our case here. So the point is, if I get to select like 1,000 rows after applying these features, I already know the values with these features that I don't. So if I get to get a few thousand rows, I will see my visuals be very responsive, and the user will not have to pay that penalty to wait for the entire database to be processed and scanned and do the aggregations, which is the penalty when you usually do direct query. So that's a very good thing. Let's take a look on that one, which is the last demo for today. So let's take a look on that one. So this one here, this was the previous one, right? And the idea here was I was doing direct query on these trips because it's too big to fit in memory, and I would probably try to do a import on these small ones in here. It's still indirect. So let's go ahead and, okay, that's a good thing. was responsive on this one. This one still have problems to refresh. Let's try it again. So let's go ahead and go to the last one. Oh, there we are. Fail. That's the one we are looking for before, right? It failed. Actually, the error here says it failed for timeout. Usually the error you see here is the memory overflow, right? You get too much information put in memory, but in this case it was just a timeout. So that was the end of demo number 1. Close this guy. Nope, don't want to save this one. And let's go to the last demo, which is demo 02, this one here. So here in demo 02, you see I'm bringing not all the dimensions that are there available in my data set. I'm just bringing a few of it. Actually, a few of the dimensions. I'm bringing all the dimensions that are available, but I'm going to start with some of them. And just to make sure we are clear here, I'm going to go here into Advanced Editor and show that in Power BI, I'm still bringing data from Synapse, right? I'm still bringing the data from Synapse and getting data from a particular dimension table in there. And my trips table is also there in Synapse. Bring the data from there. Advanced Editor. There we go. Bring the data from there. Now, I'm gonna go ahead back to the model. This is the Power Query, right? Bring the data in. So I'm gonna go ahead and head back to the model. So the trick here on the model is this, to leverage aggregates. Let's get it here. So again, this table here, the trips table, is the one that doesn't fit in memory. So there is no way for me to import this table. I will leave this table as direct query. It doesn't fit in memory. We have seen it was a timeout, but it wouldn't fit in memory. Like I showed you on the slide deck, what I'm going to do here is create a second table based on queries 2. So it came from there. I see trips aggregates. There we go, trips aggregates. And this second table here has the measures and the smaller collection of the dimensions that people would usually use to browse the data. So this table here, like I told you, it should be designed in a way that this one would fit in memory. So this one, I want to go ahead and make it a import table, right? It was a direct query. As I brought everything as direct query. I want to make this one here an import table. This is a one-way, one-time only, no Control-Z operation. When you do this, there is no way to come back, right? So make sure when you design these things, you know what you're doing. There's always, unsupported ways to roll this back, but you shouldn't. And there it is. Creating the connection, load into the data model, and it's going to bring the data in. The next thing to be done after this table is being brought in is to identify that each one of these columns in here that I'm bringing in from the table, they refer to, can I scroll it? No, I can't. While this thing is up, I can't. So they refer to the same columns that there are over here. I will have to set up this table as an aggregate table over the one that I cannot import. And now I have to wait for this to finish. And hopefully it will not take too long. That's when we depend on the service for the service to work. And sometimes the service just doesn't work fast enough for the demonstration to work. No matter how many times you rehearse the thing, you're always, a hostage of the performance of the service in the back end. So let's wait. While we're waiting here, let me see if there are any questions. I got a feedback there from Ernesto earlier that he was able to see my desktop. Thank you for that, Ernesto. Let me see. I think there are some other questions in here. Oh, not just Ernesto. Got a bunch of people there talking back to me. Thank you very much. Let's see here. Let me expand the pod. Come on. All right, it's visible. Yes, 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 yes. Can you please show how to have set up the trips aggregated table? Yep, that's what I'm doing, Ramesh. We are just waiting for that, right? The first thing is to make that table import, and we're waiting for Synapse to reply back. So that's what I'm doing. Yeah, so no more questions in there. That's the only question that's pending. Okay. Yeah, that's taking longer than it should. Usually it doesn't take more than 2 minutes to collect the table from aggregated. Let me take a look here just quick. Let me open up here another Power BI to double check that data source. Just waiting for Power BI to brought up. So another one from Fabian. Do you have any experience embedding Power BI into a window app, WPF? Yes, I have done that before a few times for customers. Actually, this shirt here is the logo for Power BI embedded that I got from the product team when I was getting instructions a long time ago about how to do that. If you have any specific question on that topic, you can go ahead and put the question in there. The thing with the WPF is you always have to be online. Your WPF application always have to be online because you depend on Power BI service. So your your WPF application will hit a REST API endpoint that will talk to the data source, collect the data, render the visual, and send the visual for your WPF to show on a HTML rendering box, right? So it's kind of a simple architecture, but you have to be online, right? The application has to have internet access. What options do we have if we build the aggregation use distinct count? It fails due to memory consumption. Yeah, if it fails due to memory consumption, is because your data set is still too big. You have to reduce it or increase your memory capacity at the service. Memory consumption, if you get memory consumption too high, another thing you have to pay attention is kind of a not really related to aggregations, but if your aggregation data sets is in the same capacity with other data sets, and it's a busy, noisy neighborhood, it could be the case that your aggregations cannot refresh because there are other data sets running in the same memory space. I have seen that happening in other clients. How did you create the trips aggregate in this model? Great question, Dimitri. And the trip aggregations is actually, let me see if I can show it from here. Recent sources. So let's go back to the Artex. There we are. All right, so okay, so that one's finished. Now this one is import. All right, took a while, but it's import. Perfect. Trip aggregate, see, it's right here. Trip aggregated is a view that I have created in Synapse. So like I said, this one is based on my fact table, and this is a select statement just with the columns that I have decided with the business team, with the users, they want to have in the aggregations. So that's how I have done it. Okay, Luis, it's just a viewing there. I do have two other questions here from Dimitri and Fabian. I will go to your questions in a few. Let's take advantage that this other one here finished, right? So now we have these guys here I have this aggregated table here as an import. And what I'm going to do now is I'm going to manage this table here and say that this table is an aggregate for this large one that doesn't fit, that will stay in direct query mode, right? So let me go ahead in here, right click this guy, and I should see here manage aggregations, right? So when I get this table, and it's that loose, right? I just make the table, make sure it's import, and then I start pointing to which table this table is an aggregated of. So I can go ahead and start doing my things in here, like let's see, from bottom up, total amount. Total amount is a sum from the table trips, yeah, total amount. There we go. That's total amount. Yeah, that's total amount. This is not total amount. This is supposed to be tolls. Oh, that's tolls. Yeah, that's done. Tip amount. Oh, look at that. I forgot about this. I have already set this up for us, right? So we don't lose much time in here. But that's how it works. You see, the extra is a sum of trips. The same table here. It could be from other tables, but it's for more complex scenarios. In this case, here made it simple to go all to the same one. So all of this columns in here. See, you can see them here, and they're listed in here. They are set up in here as either sum or group bys, which is the dimension, right, for the other table, for the aggregated table. So these are all set. And of course, I did that beforehand in order to save time for us. I was trying to save time on both, but then I was like, if I get this thing ready, there will be not much fun. Another thing, one last thing here to call your attention to before we see the visuals, is that these dimension tables that are in here, they also must have a specific setting that will tell Power BI this. If this dimension is used against this table and the columns I'm bringing from this table are already in trips aggregate, I want the data on the local import data set to be used. But if it is one of the columns we did not bring into the aggregate, this table must be sent, the query to this table must be sent down to the data source, in this case Synapse, because we need the filtering and the join to be done at Synapse side. We don't want to bring the data in to filter in Power BI. That would be too much work. So these tables, these dimension tables, they're all changed. They should all be changed from direct query to dual. So what is dual? What's the meaning of changing these dimension tables? All the dimension tables should be like that. What's the deal of changing these dimension tables to dual? This is exactly the meaning of it, right? So when people use on their visuals columns and dimensions from the trips table that have been imported, one portion, dual means two parts, right? So one portion of it have not been imported, work in memory. If they asked for columns or dimensions that were not brought into the data set, so send the whole thing down, that's the other part of dual, to the original data source. So you start changing all of these dimensions in here to dual, and then that supports separating, right, the queries from either in-memory or the external data set. And the demo gods are not helping me today. I did not sacrifice enough bacon for them, and yeah, it's taking longer than it should. All right, so what's doing this one here? Let's see some other questions. We're about almost at time to wrap it up. So let me see. I was with Luis, I think, or Luis. Let's go to Dimitri. How did you create? Okay, I got that one. Next one is Fabian. Great. I have a ton of problems with the tokens, licensing, or something else. Having tons of problems with the tokens. Tokens kind of refers me to authentication, right? Security. So I'm not sure how that goes in here. Let me get you another Power BI here while this one is processing. Let me go back to one, for instance. So when we go and say, you know what, I want to get a new data source, and that's going to be a SQL Server. For this case here, Synapse, that was my data source. I get my data source in there, and I can go and define which kind of authentication I want to do here if it's a new source, right? It's a source that has no memory about. And that doesn't go into tokens are negotiated underneath the environment, but not really there. Another aspect perhaps is when you are in Synapse itself, not Power BI, so that's outside Power BI, that's in Synapse. When Synapse tries to hit the data lake, it will use a managed identity to get to the data lake. If the managed identity was not granted permission into the data lake, you get errors from Synapse saying that Synapse doesn't have permission into the data lake. I cannot show you that here because my environment is well set, so it has that permission. But if you see something like cannot hit the lake, it could be something from here, right? From the Synapse environment. All right, next one here. What are the key differentiators of connecting Power BI to Databricks, Azure SQL, or Synapse? All right, key differences on that one. Azure SQL, for the most part, they are pretty much the same, right? The difference in this case here, Louis, the difference in here is just the data engine that's behind the scenes. So SQL, for instance, SQL keeps the data in its own storage place, right? You're not hitting the lake, you don't have problems with authentication with the lake and things like that. It's just whatever is in SQL or in Synapse dedicated pool. So in that matter, you are connecting and working with the relational databases, and a lot of people are very comfortable doing that. When you go into, and for that matter, by the way, Synapse works pretty similar, right? Because SQL and Synapse, they use the same protocol. The Synapse has multiple engines inside. One of them is the dedicated SQL pool, which behaves for the most part almost identical to regular SQL Server, so no difference in there. When you go to serverless SQL pool like this one here, you have some statements that are different. So it's like less compatible with a regular SQL, but still can do a lot of things like SQL. And the thing with the Databricks, when you do Databricks, the only thing with Databricks is a compute engine, right? It doesn't keep its own data besides the metadata for the workspace. The data is actually kept in the lake. So when you are using Databricks to collect data from the lake, like I'm using Synapse here to collect data from the lake, you got to make sure that your Databricks cluster is up and running, right? But besides that, you do have the connector in Power BI. Let me go back there to the virtual machine here. You do have the connector inside Power BI. If you're, let me see one here. I was working on this guy, I think. So if I go here, get data, and go more, you will see here that Databricks. There we go, here it is. Databricks would show up, right? And then in this case here, it's all specific to Databricks, where it's your cluster, you're the server host that you are cluster, and what's gonna be the query you're gonna run in there, right? So that's pretty much the difference, right? It's just what data engine you're working with and how you communicate. Once you tap and bring the data in as import, you're good to go. All right. This is for embedding, exactly. Fabian, my shirt is for embedded. Did you ask for embedding? Yeah, embedding, there we go, Power BI embedding. So I hope we're on the same page there. And the last one from Avery, do I have to use star schema or snowflake schema? Will this work in OLTP environment? So right now I'm working with the data lake, which is not OLTP, right? It's a data lake. I could be hitting SQL Server, and that SQL Server is designed for OLTP. And in SQL Server, I would have a star schema model associated to it, right? So star schema is actually more like a model. It is actually a data model than a particular data engine. So it works on multiple data engines. The thing is, when systems work on LTP, they are focused on supporting quick data updates and consistent data updates. So they look for avoiding data duplication. While we do star schema like this, we rearrange the data in a new model where data duplication will happen, right? It's acceptable and actually desirable because you are not looking to change the data, you're looking to query the data as fast as possible. And although it's not that intuitive, it seems like if you have more data, it's going to take longer to process. But depending on the data repetition, the compressions that happen, it makes things faster, right? So yes, you can use OLTP engine and model the data there in star schema and leverage in Power BI. Even if you don't remodel it, if it's a small data set, it will still work. But in terms of aggregations, this particular feature, you want to have it remodeled. All right, no problem, Luis, you got it. Next one here, Jerry, can you explain again how Power BI report can dynamically choose? Yeah, so it dynamically chooses, Jerry, it dynamically chooses if it's going to the on memory, right? In memory imported data or the underlying one based on the columns you get in your visuals. And also the dimensions, they also must be dual, right? So like this one here, let's zoom in here just quick and we'll see that. I probably will be able to do a visual on that one too. So let's take a look in here. So this guy, trips aggregate, has these columns in here, and it's based on this table that has way more columns. So let's try to pinpoint a column that is in here that is not there. Let's see, Fairmount. Fairmount is there. Yeah, this session will be recorded, Mark. We would have to find a column here that I have left off. Let's see, ones like start latitude. So if I want to aggregate by the the latitude longitude of a particular ride, I don't have that information in my trip aggregation, you see. So if I use these columns, because these columns are not in my imported table, Power BI knows it has to go back to the underlying table. And because I told Power BI before that this table here, manage aggregations, this table here summarizes, is an aggregated of the other one, this is how Power BI knows when to go to the one and when to go to the other. Notice too, that's a very important question. Thanks for the question, Jerry. Notice too that once I made this one here, aggregated table, it got invisible. See this flag here, say it's invisible. And it does show up in here for me, but see, it's not going to show up when I go into the model design, report design. When I go, and that's where the users would go to create the reports, right, and deal with the reports. So as you can see over here, I don't have trip aggregations showing up. I only have trips. And if I only bring columns from here that are in the trips aggregate, I will have blazingly fast response because it's going to be work from memory, right? So let's say here I want to have a label. I think that's a label, right? Card, sorry, card. And I'm sure that Fairmount was there. So if I select Fairmount into the card, I get the response super fast, right? And I can actually see that if I go into View and ask Power BI to show me the performance analyzer for my visuals. and do a clear and refresh, I can see that my card worked of data within memory. There was no going out of Power BI to do that because the column I brought in is in the import. And look, I'm using the trips table. I'm not using the trips aggregate, right? Because I already told Power BI that trips aggregate has some of the columns of trips, so Power BI knows when it is one and when it's the other. If I change that for this one, for the column I did not bring, so now I see the spinning going on, and unfortunately the underlying table, underlying data engine is kind of working slower for me today. And as you can see, it will take longer because it's doing a direct query to the underlying database. Thanks for helping me out. That was the last portion of my demonstration. So you can see that the X is working, right? When you work with the things you compromise that you query the most, query most often, it works super fast. And there we go. Now this one took 31 seconds to get processed, while the other one was a 10th of a second. All right, Jerry, thank you very much for that one. And Mark also already mentioned it. This is being recorded and we made available. All right, if there are no other questions, thank you, Fabian, for the feedback. Really enjoyed this demo. All right. Thank you very much for your good job. I hope you have enjoyed this one. The rest of you guys, I still have 40 people there. It's kind of the same amount of people we get when we started. Sorry, run 10 minutes over our time, but I hope that's been informative. And if you need more information, you want to chat with me about that, please go ahead and connect with me on LinkedIn. And enjoy the rest of your day. Today is Friday Eve, so tomorrow is Friday. It's kind of the beginning of the weekend for most people. So enjoy your weekend. Stay safe, everybody. See you in the next webinar.